everyone, we are starting Module 5, which is on triangle congruence criteria. So we're basically figuring out whether or not triangles are congruent to one another. 5.1 is just about exploring what makes two triangles congruent. So we're going to start up with a little warm-up, a little bit of review from previous units. You guys have seen these congruency statements before. Triangle DEF is congruent to triangle MNO. So let's complete the statements. Remember, the order of the letters is important. So if E is the second letter, then angle E is going to be congruent to angle N because it's the second letter in the other triangle. Segment DF, that's the first letter and the third letter, so that should be congruent to the first and third of the other triangle. So side DF should be congruent to MO. So I just wanted to review these congruency statements and how you can use them to tell what's congruent between two figures. In this next example, we have two triangles, triangle ABC and triangle PQR. So let's just list all pairs of congruent sides, and then we'll do angles after that. So for example, side AB should be congruent to side PQ because AB is the first two letters, PQ is the first two letters, so those two guys should be congruent to one another. Okay, we also got BC should be congruent to QR. Those are the last letters. So this side BC should be congruent to QR. And then last we got side AC. That should be congruent to side PR because they're the first and the third letter. For angles, same deal. We got angle A is congruent to angle P, because those are the first letters of our congruency statement. We got angle B is congruent to angle Q. Those are the second letters in our congruency statement. And then finally, we got angle C is congruent to angle R. Those guys are the third letter. So those are all the congruent sides and all the congruent angles between those two triangles. What we'll do in this lesson is you guys will learn the triangle sum theorem and use that, decide if two triangles are congruent, and then solve for values of variables that make two triangles congruent to one another. So we're just going to start off with a few definitions. You guys know what a triangle is, you've seen it before, but formally it's a figure formed by three segments joining three non-collinear points. So three non-collinear points, they just all can't be in a straight line. And you got three segments joining those guys. So you guys know what a triangle looks like. Not a new idea. We can classify triangles by sides and by angles. So if a triangle has three equal sides, we call that triangle equilateral. If a triangle has at least two congruent sides, we call that triangle isosceles. And then if all three sides are different, we call that guy scalene. So these are the three different ways we can classify a triangle by sides. Equilateral if all three sides are the same length, isosceles if at least two sides are the same length, and then scalene if all three sides are different. We can also classify a triangle by angles. So we call it an acute triangle. We call it acute if all three angles are acute angles. We call the triangle equiangular if all three angles are congruent, and that can only happen if all three angles are 60 degrees because all three angles have to add up to be 180. So if all three angles are 60, that makes the triangle equiangular. There's also a direct relationship between equiangular and equilateral. If a triangle is equiangular, it's also going to be equilateral and vice versa. Right triangles have one right angle. We've used these guys a ton of times before, so you guys know that one. And then lastly, we have obtuse. Hopefully you guys can see that behind my face. An obtuse triangle has one obtuse angle. So as long as one angle is greater than 90 degrees, we call that triangle obtuse. Next up, we have the triangle sum theorem, which says that the sum of the measure of the interior angles of a triangle is 180 degrees. So if this is angle 1, this is angle 2, and this is angle 3, by the triangle sum theorem, we know the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. All three of those guys should be equal to 180 degrees. And we're going to prove that right now. So here's a little picture I'm going to use for our proof. We got the three angles of our triangle labeled 1, 2, and 3, and then I'm also going to label these guys 4 and 5. We got this line here that's parallel to this bottom side of our triangle. So we're given the fact that AD is parallel to BC. We're going to prove that these three angles add up to equal 180 degrees. So it's not a super long proof, it's only 5 steps. And you guys know the first step of every proof is to write the given. So we got the given here. Okay, next step, think about all the stuff we learned about when we had parallel lines and transversals, because we got these two parallel lines, line AD, line CB, we got two transversals here, correct? So first off, I know angle 1 is going to be equal to angle 4 because those guys are alternate interior angles. So by the alternate interior angle theorem, those guys are going to be congruent to one another. I can say the same thing about the measure of angle 2 and the measure of angle 5. Those guys are alternate interior angles as well. And then we also kind of got this linear trio up here. Angles 3, 4, and 5 make a straight line. So I know that they have to add to equal 180 degrees. My reason's just going to be they make a straight line. So we know they add up to be 180. And then you can see we know 1's equal to 4, so can't we substitute 1 in for 4? We know 2's equal to 5, so can't we substitute 2 in for 5? So the measure of angle 3 plus the measure of angle 1 plus the measure of angle 2 all equal 180 using substitution. We just proved that the three angles of a triangle have to add up to equal 180 degrees. So let's talk about how we decide if two triangles are congruent to one another. For now, we know that two triangles are congruent if and only if all the corresponding pairs of sides and all the corresponding pairs of angles are congruent. So you basically have to check the three sets of sides, you have to check the three sets of angles, and you have to see if they're the same between the two triangles. So let's do an example. We'll determine whether these two triangles are congruent. So let's go ahead and see. Let's check sides first. So let's check side JH. We can see that that side's congruent to LM because they both have a length of 1. Okay, we also know that side GH is congruent to side LK because they're both 1.7. And then last we can see GJ is congruent to KM because they're both 2. So we've checked all the sides, we can see that those guys are congruent. So now let's check our three sets of angles. Okay, we can see angle L and H are congruent to one another because they're both 90 degrees. We can also see angle M is congruent to angle J because they're both 60. And then we can also see that angle G is congruent to angle K because they are both 30. So you can see we've checked all sets of sides, all sets of angles. They're equal between the two triangles. So we can go ahead and write our congruency statement. Triangle GJH has to be congruent to triangle, and make sure that your order is correct, because if we wrote G first here, that's the 30-degree angle, so we have to write K first for this triangle because that's the 30-degree angle. J is the 60 degrees, so we have to write M next. H is the 90, so we have to write L next, and that way our triangle congruency statement matches. We can see which angles go together between the two triangles. Our next example, we are going to find the value of the variable that makes these two triangles congruent to one another. So we got two 55-degree angles, we got two 45-degree angles, so that means that angle L has to be congruent to angle P because they're the last two last two angles, so those guys have to be congruent to one another. So let's first figure out what L would have to be, because we know two angles are 55 and 45. So the measure of angle L is going to be 180 minus those two other angles, which gives us, so 45 and 55 gives us 100. So angle L must be 80 degrees. Okay, we got angle P and angle L. We know they're the same, so that means that these two guys, P and L, have to be equal to one another. So 5x plus 30 has to be equal to 80 degrees, and then we can just go ahead and solve our equation. So 5x would have to be equal to 50 degrees. Oh, time to change classes. And then x would have to be 10 degrees. So x being equal to 10 would guarantee that these two triangles are equal to one another. You can see that all three sides are congruent between the two triangles, and now all three angles are congruent. All right, for these two guys, we got two sides that are 30 degrees. 30 millimeters. We got two sides that are 50, so that means that these two sides have to be equal to one another. Side AB has to be equal to side DE. That will make the two triangles congruent. So let's go ahead and set those two values equal to one another. 2y plus 20 has to be equal to 36. Subtract 20 from both sides, which means y would have to be 8. So y having a value of 8 would guarantee that this side is also 36, and then we can see all three sides and all three angles between the two triangles are congruent to one another. All right, our last example, we're going to see if these two triangles are congruent, but they're just in the coordinate plane. So we got angle A is 33.7. We got angle F is 56.3, and then we know that we have two 90-degree angles here. B and E are both 90. So let's write in A, 33.7. Let's write in F, 56.3. So let's go ahead and see if C and D are congruent. So if we go ahead and let's just solve for D first. The measure of angle D is going to have to be equal to 180 minus the other two angles. So minus this 56.3 degree angle and minus the 90 degree angle. And if we do that, we see that we do get 33.7 degrees. So we can see that all three sets of angles are congruent to one another. So angles are good, those check out. But now we have to check sides. So let's go ahead and start checking those. We're gonna have to use, let's use Pythagorean theorem. Let's do side AB first. So I'm gonna go ahead and draw my right triangle here. You can see that I get side lengths of 3 and 3, so 3 squared plus 3 squared. So we get 9 and 9. There's the warning bell. So we get AB is going to be equal to the square root of 18. And we can see here side AB should go with side DE. You guys can see if you draw the triangle for DE, see how you also get side lengths of 3 and 3. So that means DE is also going to have a length of root 18. So those two sides check out. Let's do side BC next. BC squared. Let's draw our triangle for that. We got side lengths of 2 and 2. So 2 squared plus 2 squared. That's going to give me 4 and 4, which is 8, so square root of 8. And you guys can see that goes with side EF. If we draw the triangle for EF, we also get side lengths of 2 and 2. So EF is going to be the square root of 8 as well. Okay, last one we got to check is AC. If we draw the triangle for that guy, we get AC squared. Sorry, those bells are a little annoying. We get side lengths of 1 and 1, 2, 3, 4, 5. So 1 squared plus 5 squared. That gives us 25 and 1. So AC would have to be root 26. And you guys can see side DF matches because it also has a triangle with side lengths 1 and 5. So DF is going to be square root of 26 as well. So you can see we have 3 sets of congruent angles, 3 sets of congruent sides. That tells us triangle ABC is going to be congruent to triangle DEF. And that's the last example. So now you guys have your homework, 5.1 on HMH. Let me know if you guys have any questions.